Good morning, all of you. Very welcome. I am Robert van Hasselt. I'm the external project leader of the Wind4Shipping project. Wind4Shipping is a partnership of 12 partners in a special public-private cooperation. We have ship owners on board, wind propulsion suppliers for wings and rotors, public bodies, universities, and certification organizations. So from very different perspectives, we can work on the development of wind propulsion technologies. Our partners come from Germany, the Netherlands, Belgium, and France, and our overall budget is 5.7 million euro, and it's financed by the Interreg Northwest Europe program from the European Union. Our main goal, because we had already the validation phase in the wind propulsion technologies, is now to upscale wings and rotors, both in sizes and in amounts. And that's because, well, when you upscale, of course, you can decrease costs and you have a faster return of investments, and that's important for everybody who wants a viable business model.
Good morning, everyone. I'm Robert Bronz from Lautingen Shipping Group in Germany. I'm in the nautical and insurance department and also a project manager on behalf of Lautingen Ship for the Wind4Shipping project. Yeah, we are going to talk about our new building Nike, where suction wings will be deployed soon, and yeah, looking forward to that.
Good morning. So Felix, so we are a French manufacturing company, so equipment manufacturer for the maritime. We provide a rotor sail, so very light and super powerful. So typically up to twice as powerful as any other, let's say, system actually deployed. So we are within that Wind4Shipping project, let's say, scaling up both the production phase, so we're just industrializing our first sales in France, and glad to be here to share, let's say, the expertise about project inception and project integration for wind propulsion system on board ships.
Hello, good morning. My name is Frank Nieuwenhuis. I'm the founder of EconoWind. Some 10 years ago, we participated in the first WASP project, also funded by Interreg European Union. After this project, we started to scale up. So we're very familiar by now in the upscaling. In the last 2 years, upscaling really takes place. Lautingen is one of the customers that will be installed shortly. In total, we have 150 units sold. We have some 80 units installed that are actually sailing on some 25 different ships. And we hope to put it further on that wind propulsion will be going towards more of a commodity than some special research situation still. So looking very much forward to this webinar and further upscaling.
But first of all, I'm very curious to you as an audience on ship owner company, 6 research institutes, maritime industry technology providers, consultancy, policymaking organizations, industry. Okay. Thank you very much. Then now I would like to give the floor to Lauteringen, to our front runner in the project from the ship owner perspective.
Lautingen Shipping Group, a family-owned shipping company since 1979, based in Emden in Germany. We do ship ownership and ship management. We have a fleet of 25 dry cargo vessels, different kinds of vessels, general cargo, smaller Eurocoasters, multi-purpose vessel, with piers, bulkers up to the size of cape size, and PCPC, so car carriers. And the trading patterns of our fleet is worldwide, mostly in tramp shipping, so in the spot market, but also some of the vessels are in liner service. So we started with the green shipping quite early as a front runner, as an intermediate solution. We use LNG on our car carriers. Our company, we have a close relationship to the local University of Applied Sciences here in Emden and Leer. The Nike new building project, it was launched at the beginning of this year in February. A general cargo coaster vessel with very efficient aquadynamics. Maybe Frank, you can say shortly something about how the suction wings work.
Yes, of course. Well, basically, it is like a wing. A wing, when there is an airflow over a wing, you get a lower pressure on top of the wing and a little higher pressure on the bottom of the wing. And normally that's why an airplane flies. So we put it upright. So now when there is wind, which has a flow around this wing, you have the same. There is a lower pressure on one side and a higher pressure on the other side, giving a force of the wing, and depending on the angle of the wind relative to the ship, there's a bigger or smaller component of that force moving as in the forward direction as a propulsion force. The wing itself is made from aluminum, so we try to keep it as light as possible. Our wings is that it is foldable.
Yeah, why we choose this technology, Frank explained a lot already. Maybe we can add that Wind and their ventrifoils are a proven technology, which is already in the process of upscaling. I think they sold well more than 100 units. Also now the price is becoming more and more competitive. And also it is a manufacturer from our local region here, from Northwest Europe. And yes, an easy cooperation with them. The suction wings will be deployed only later this year in the Netherlands. Most likely in Harlingen. Why to consider wind-assisted ship propulsion at all? First of all, because of regulatory pressure. On top of that, we also have, of course, our own strategic direction, and we want to be de-risking, especially in the face of fuel price uncertainty, which is a very top urgent topic now, of course, since the war in Iran started and the fuel prices exploded. And we want to have a future-proof fleet. We always one step ahead of our competitors in future developments. We calculate with 180 days of the wings in operation of 240 sailing days. The remaining days per year will be in the port for maintenance of the vessel, for example. Annual fuel saved, so 180 days times 4 tons of daily consumption of marine gas oil. And we calculate with 10% fuel savings per ton. So then we come to 72 tons of marine gas oil saved per year on this vessel. And then we get 226.8 tons of CO2 saved per year.
There's a question from Felix Agostini from Marico. He asks, do charterers or customers explicitly ask about the use of wind propulsion technologies, or are they solely concerned with reducing CO2 emissions regardless of how? Are customers showing at least some willingness to pay more for greener shipping using WASP?
Generally, charterers are willing to reduce their carbon emissions. The charterers are not rewarding the owners as it, from our point of view, should be. We don't charter the vessel out to a third-party charterer, but we will keep the vessel in-house because we also have an in-house chartering department. And so they will be in charge of the vessel, and all the savings remain on, let's say, in-house, on owner's side, or on our chartering department.
Thank you very much. The second question is, how much higher are the capex costs? Are these merely additional costs for the wind propulsion systems, or are they further relevant costs arising from the integration of the WASP system into the ship?
Integration, let's say between 15 and 40%, depends on a lot of small assumptions. The clear message is just make the ETS also cover smaller vessels below 5,000 gross tonnage, and you don't need subsidy anymore because the ETS will do it automatically. On a national level in Germany, we have the NAMQ subsidy program, which grants 50% of hardware installation, which have to save CO2 emissions by at least 10%, which is the case for the ventrifoils.
In the case of France, they decided to basically redirect the money. France is leading on that front. I'm not aware of other countries that are doing that for now. But of course, let's say the NAMQ has been there for a long time and might be coming back through the KTF. So we expect that similar frameworks will be put in place across Europe.
The NAMQ was really an example in itself, which really stimulated CO2 reduction generally.
Yes.
But like the NAMQ is not at this moment, we are waiting for something to be set up within the EU. And we're really hoping because it is worthwhile.
In the future, we consider additional WASP deployment, more ventofoils, bigger ventofoils, other suction wings, and other technologies like rotors, for example. Evaluation is in progress with Wind, and we are looking at hybrid energy concepts, shore power. Also for this vessel, there's already a battery room installed, so it is ready for shore power. We are looking at solar electricity generation, especially for the bigger vessels. WASP is already technically proven, but it is only now becoming commercially relevant due to regulation and market pressure. Payback time and return on investment, we expect to improve that very soon.
Good morning, Mark Streuper, ABB, Marine and Ports. My angle of attack on this topic is weather routing, weather data. My question is, what are the biggest operational challenges?
There's lots of things to consider. For example, how does it work in harbor? They have to fold away, so that is an operational thing as well. It has to be really simple. Crew training and the usage is a very important thing. And we have noticed that since we have the platform, we are really reading out how much is the system actually used. And that depends a lot. The amount of times when you can really use it as a result of where you are. For example, in the WASP projects, we found out that the one that was doing that was some 30 days a year within the Kiel Canal. Yeah, so these are also operational things. But the assumptions that Sunship has done, what he said is that he would run for about 180 days a year. That is for short sea applicable. It's a few stretches across the ocean, make very good statistics. But if you stay within the harbors here in the north of Europe and you go from one harbor to the other harbor, those operational things, of course, are very important on the total amount of time that you can use it.
One of the challenges is the, let's say, automated learning of the software that will run the sails, basically. So that's true for the suction sail, but also for the rotor sail. And the challenge of having, let's say, holistic optimum, not just optimizing the performance of the sail themselves, but optimizing the performance of the ship. So you need to have, let's say, some kind of integrated data platform, so similar to what Frank has mentioned, so that you have, let's say, the holistic performance and the best savings overall, not just for the sail.
Yeah, it's good to see your stakeholders and especially shipping companies in the case of wind propulsion. I have the question if especially the technology providers like Econowind, but maybe also Farwind, if you have the feeling that the actual situation and the, I would say, non-decision on IMO level concerning a net zero framework, do you have the feeling that that makes declining demand for WASP technologies?
We have been investing in upscaling already for a few years because this was coming, and we have seen in ATS and NAMCO it has had, of course, an enormous effect on the business case. So there is definitely, of course, a very big effect of these kind of rulings.
Yeah. I think we could add to that there has never been more investment in wind propulsion than today, but it could have been accelerated even more with that GFI program in place. So we're still expecting it, but the shine is still, so wind is still blowing and the sun is still shining. So.
Yeah, and that is the absolute truth. And it's very good that Len said that at the end, wind remains free, but we had expected it to double or triple as a result of these kind of regulations. They have an influence, of course.
Thank you very much for attending us and to get some learnings from how we are developing in the wind for shipping. And Len, Frank, and Felix, thank you very much for your contributions. Thank you.
You're welcome.